I'm Anil Kumar sharing with you a question asked from my student Amandeep. Amandeep, this is indeed a very good question. The question here is determine the 10th term of a sequence 3, 10, 28, 72, 176. State the geometric series. Now, how to find a general term, rather the 10th term in this case? What we will do is we'll find the general term for this series. So the series given to us is, let me write it in kind of a column, so it'll be easier for us to figure out. So whenever you have a series which is not very straightforward, what we should do is we should try to analyze it. The terms are 3, 10, 28, 72, 176. Now how do we get these terms? That is kind of what you have to figure out. So what we see is, and we have to relate with the term numbers, right? So let me write term numbers on the side. So this is the first term, this is the second term, third term, fourth term, and fifth term. So try to relate them with the number. So with respect to number, how do you get your answer? That is what you have to figure out. Now you could get, for example, 3 as what? 1 times 3, right? So you could get 3 as 1 times 3. So, and how do you get 10? You could get 10 as 2 times 5, correct? This is times for us. Okay. How about 28? 3 times, well, 28 is not a multiple of 3, so that doesn't work. On the other hand, we are having 3, 5. Can we get something on the right side? 28 has only few factors, 4 times 7. So let's continue with 4 times 7. It at least makes a pattern to the right side, 3, 5, 7. Now since we are getting a pattern here, 72, let's see 9 times what is 72. 9 times 8 is 72. 176, 176, 1 plus 7, 1 plus 6 is 7. So it is 11. So 11 times what is 176. We can use calculator, right? So we will do 176 divided by 11 and you get 16. That makes sense. Now you will notice that we are having product of two numbers. Well, let us say numbers are x times y, where this series of x is kind of 2 to the power of 0, 2 to the power of 1, 2 squared, 2 cubed, 2 to the power of 4. And here we have set of odd numbers. Do you see that? Now looking into this pattern, you can now figure out what x and y, these two factors are, right? So in general, what we notice here is these are powers of 2. So if I have the nth term, let us say, in that case, what should be my formula? Now this is 2 to the power of 0, 1 less than 1, right? 2 to the power of 1. So we get 2 to the power of n minus 1 times, so we get the first series, right? This is 2 to the power of 4. Or let me write it once again. So what we are getting here is, we can write this as 2 to the power of 0 times 3, 2 to the power of 1 times 5, 2 to the power of 2 times 7, 2 to the power of 3 times 9, 4 times 11, right? So what we notice here is that the first factor is 2 to the power of n minus 1. From 5 we get 4. Now how do we write these odd numbers? Odd numbers are 2n plus 1. 2 times 1 plus 1. So these numbers are 2n plus 1. So that kind of gives us the general formula. So now using this we can write Tn equals to 2 to the power of n minus 1 times 2n plus 1. Do you appreciate that? So that is how we can actually develop a formula, and this formula really helps to generate the given sequence. Now if you say find the 10th term, that means you also n as 10, right? In that case we'll get 2 to the power of 10 minus 1, and we get here 2 times 10 plus 1, correct? So that is 2 to the power of 9. 2 to the power of 10 is 1024. Remember that, okay? And here we get 20 plus 1. Well, we can use calculator. So let's use calculator and multiply 21 by 2 to the power of 9. 2 to the power of 9. What do we get? We get this equals to 10, 7, 5, 2. So that is the 10th term for the given sequence. Do you get the idea? So that is how you can actually develop and explore these sequences. Thank you, Amandev, for sharing this question, and you can practice the other questions from your book, and in case there is any difficulty, let me know. I'll be more than happy to help you out. Thank you and all the best.